Hello.
Hello.
Yeah, I can hear you.
Hello. Hang on. Let me increase the volume. Speak.
Sir, I'm really grateful that you are taking the live session.
Hi. Can you introduce yourself?
Yeah, I'm Sir Swarnim Maheshwari. I'm a undergraduate in BTech. I actually took your course because I was interested in machine learning
Uh-huh.
and theoretical foundations of machine learning.
Mm-hmm.
And I wanted to do a course in measure theory.
Mm-hmm.
And I was recommended to like this course.
Mm-hmm.
And I till now I find it like very useful.
Good, good. So where are you from again?
I'm actually from Rajasthan, Bhilwara.
Okay. Where are you studying? Your undergrad, you said.
Yeah, I'm an undergraduate. I'm studying from Sangam University, like
Ah,
local university in Bhilwara.
okay. Are you able to follow broadly?
Um,
The lectures are a little bit advanced for undergraduates, right?
yeah, they're certainly advanced, and I do regret that I did not take a real analysis course beforehand. But yes, I'm able to follow for the most part.
Okay. Real analysis again you can do in on NPTEL, but you don't need that much real analysis. Maybe chapter 2 of Rudin will do.
Yeah, I actually also read your notes for real analysis on your
Right.
website.
Good, good, good.
Yeah, yeah, but I still find like those to be a little bit shallow, like for the depth you're going
Correct.
in.
Hmm.
Uh,
So you could look at Rudin chapter 2 or Tau if you want a little more real analysis background.
yeah, I also find like lack of references to be a little bit more like difficult to find because like the book you mentioned in your first lecture, like that does not even cover like the sigma algebra. Like the algebra, but does not even come in that book. And like
Which
the book
book?
is more the book which you mentioned in the first lecture. Uh,
Well, Grimmett, Sterziker, David Williams, and all cover sigma field.
yeah.
Okay. Undergraduate treatments will not cover. Okay.
Mhm.
But I think it's there in the what's there in the notes is sufficient for this course. There were also some questions on. See, I didn't go deep into some measure theory concepts like this pi systems, lambda system, and all. I didn't get into deliberately, but I think there were some questions. The TA has put some questions, which I said we will not consider for grading.
Mhm.
Those pi theory, lambda theory, and all is not very. It's too much into measure theory. I feel not required. It's just that we need to know that if measure is unique on a pi system, then it's unique on the sigma algebra, right? So those sort of things come from measure theory, but we can just accept it. It's okay at this level. Okay.
Yeah, certainly.
Do you have any technical questions for me?
Yeah, I certainly do.
Mm-hmm.
Like for example, in one of the lecture you mentioned that probability, when we are talking about probability in this code, it does not necessarily mean the likelihood of some event of occurring. You mentioned like the probability of throwing a dart in a real number line and
Mm-hmm.
it getting a rational number is certainly possible, but its probability is still zero because they
Correct.
are countable and their Lebesgue measure is
Correct.
zero.
Correct.
Yeah, I have a question that like if the probability does not mean likelihood, why even like what's even the point of studying probability at that
No, no,
point?
no. I mean, I
Like,
did not say. And see, likelihood is actually a different concept. Okay, likelihood is not same as probability. Okay, so I would not use the word likelihood in a non-technical way. It's a technical term that is, used in detection theory and all. Okay, so probability. I mean, it has. I mean, intuitively, it has something to do with chance, and the probability of landing on a rational number is zero under the uniform measure. It's as simple as that. It doesn't mean that that outcome does not exist in the sample space. The outcome exists in the sample space, and that outcome, it's as a member of the sample space, it can occur,
mhm.
but its probability is zero. That's all. It should be understood in the same way as the probability of landing exactly at some singleton point, let's say half or something, is zero, right?
Yeah,
doesn't mean it cannot occur. It's just the probability of that is 0. Because if it is non-zero, then you will not be able to satisfy the, if it's non-zero, even epsilon, then any countably infinite set will have probability equal to infinity, which doesn't make sense.
Yeah, but like saying that the probability of like something not occurring, even though it is in the sampleless way, is also like very like unintuitive, right? It is almost as unintuitive as like breaking the like Lebesgue measure zero thing.
The Lebesgue measure is just length. Okay.
Yeah.
The rationals occupy a length of 0 on any countable set occupies a length of 0, right? And that is not, I think that's fine, right? If you can believe that a finite set of points occupies a 0 length, then it's not, under the axiom says that if it's a countable union of singletons, the measures have to add, right? Therefore, it's 0 probability or 0 length, right? Yeah, so it's the probability under the uniform measure is 0. So the probability of your dart landing at exactly at a rational point is exactly 0. It's not approximately 0, it's exactly 0. But is it a valid outcome? Of course, it's a valid outcome. It's an element of the sample space, right?
Yeah, like it's the like, last line that like before I took your course, the way I understood is that, for example, if there are 10 elements, then the probability of singleton occurring 1 by 10, and as you increase the element, it decreases. The probability of singleton occurring is decreases, and if there are infinite elements in the set, then the probability of something like approaches 0, and like that's why I've understood it till now. But now you say like that it is not approximately 0, like it does not approach 0.
Yeah, it is actually 0. It has to be assigned a value equal to 0, right?
Yeah, like that kind of like seems like very unintuitive to me. Like it does not approach 0, it is 0.
It is 0. By the way, in a countably infinite set, you cannot put a uniform measure. It's not possible. What you are thinking of is, taking n elements, putting a uniform measure is possible. Give probability 1 by n to each. But on a countably infinite set, you cannot put a uniform measure. It doesn't exist. But on an uncountable set like 0, 1 interval, you can put a uniform measure, where the measure of the set is simply proportional to the length, right? So if you deal with the probability measure as length, then sets of 0 length will have 0 probability, right? So all countable sets have 0 length. Even the Cantor set has 0 length. Cantor set is uncountable, but it has 0 length, right? So the probability of your dart landing in the Cantor set is 0, even though there are uncountably many elements in the Cantor set, right?
Yeah.
So that is the way it is. I think there's no inconsistency here. You just have to just accept it that this comes from the axiom and it's correct. Right? The probability is 0. You have to say it's equal to 0, right?
There's a similar statement you also made about independence, right? Like you said, like the intuitive notion of independence, that like the information about one event does not give us the information about the other event, maybe wrong in rigorous mathematical sense. Can you like give an example where the intuitive sense is wrong?
Yeah. So I think you're talking about. So whenever you say, maybe I should share my screen at some point. How do I do that? Chat, share screen. Here it is. Share. You see my screen?
Yeah, I can see it.
Does it say probability foundations?
Yeah, probably foundation live session.
Yeah, so independence, right? Independence. Okay, so for two events, we are just saying that A and B are independent under P if probability of A intersection B is equal to probability of A times probability of B, right? This is the definition, okay? So what does A and B being independent means? It means that the probability of the intersection is the product of the probabilities. So independence means multiply, okay? You can say that if probability of B is greater than 0, then this implies you can write it as probability of A is equal to probability of A given B. Correct? Because you can write out the conditional probability as probability of A intersection B by probability of B. Then this is what people interpret as saying that the occurrence of one event does not say anything about the occurrence of the other, right? That is what people normally colloquially say. My thing is that don't think about it that way. I mean, this is true if, see, whenever you're dealing with probability events of probability strictly between 0 and 1, this intuition is fine. The colloquial intuition that the occurrence of B doesn't say anything about the occurrence of A. I mean, that is just this equation, right? What is the occurrence of B meaning? You're conditioning on B. Correct?
Yeah.
So that doesn't change the probability of A given B remains the unconditional probability of A. So that's what people colloquially mean by saying that the occurrence of one event does not say anything about the occurrence of the other event. That is not correct when you're dealing with, so that really crucially depends on this. Right?
Yeah.
Probability of B greater than 0. If probability of B equal to 0, I mean, there are many situations where the events can be independent, even if the occurrence of one event says everything about the occurrence of the other event. Okay. I think I gave an example in the lecture. Yeah, so A could be, so if omega is 0, 1 and F is Borel and P is Lebesgue, then let's say A is rationals, the event that is rational, right? A complement is the event that is irrational.
Right. Yeah. You mentioned this.
Yeah. So in this case, A and A complement are independent.
Even
right?
though,
although the occurrence of A says everything about the occurrence of A complement. Right?
Right.
That's because you get 0 equal to 0 on both sides and they are independent, right? So that interpretation breaks down when you're dealing with events with probability either equal to 0 or equal to 1.
Right.
That is why I'm saying that forget about that interpretation, just apply the equation. Apply that equation. Okay. But that said, when you're dealing with events of probability between 0 and 1, this equation is correct. Right? So then you're okay. Then there's nothing wrong with the interpretation. And in discrete spaces, you don't have well-populated sets of 0 probability, right? That doesn't happen in discrete sets. So in discrete world, this issue doesn't arise.
Yeah. I also like, even though I'm able to follow the lectures, I sometimes am unable to understand like why did mathematicians choose to do it in this like way? Like for example, the random variables. Like what application did the normal events and those things were not able to solve that we needed random variables to solve?
No, random variables are simply numerical functions of the outcome. Sometimes you don't care about the underlying outcome, right? So if you're tossing a coin repeatedly, you may be getting some complicated sequence of heads and tails, but you may only be interested in the number of heads, right? Sometimes the underlying sample space may be very, very complicated, such as in radioactive decay or whatever. I don't even know what the elementary outcome is, but you are interested in counting the number of emissions. And those kind of objects are random variables.
So like it is a way to fix up, quantify some things about events without actually dealing with the individual events.
Yeah, it captures a function of the elementary outcome. Okay. So it maps elementary outcomes to numbers, right? and essentially ends up pushing the probability of events in omega to probabilities on subsets of R. Correct? So it ends up pushing the measure from omega F to a measure on R, Borel. Right? That's what happens.
I also do have one question from your lectures. Like, for example, in the first paradox we discussed, where we talk about like probability of some section, like it being in one part of the circle and being the other part of the circle, and you figure it out like it has different probability. The way you measure it, like if you measure it by the arc, it's different. If you measure it by the chord, it's different.
Right.
And then later we discussed like the reason it is giving this like paradoxical behavior is because the measure is undefined. Like you cannot like so like I wonder if it's like possible to prove like the probability is some arbitrary value. Like for example, like it's possible to quote unquote prove that like 0 divided by 0 is any number possible. Or
it's
like
not really 0 divided by 0. It's not like that. See, the three in I think you're referring to Bertrand's paradox, where that are all that. See, there are the three different calculations, all three are correct, right? They're all correct, and they're correct answers to three different mathematical questions. Okay. So in particular, a chord chosen uniformly at random. So in what space is it uniform? That's what varies in the three examples. Okay. In what space are you uniform? Are you uniform in that angle space, or are you uniform in the center of the arc being this here or no? That is what changes. Okay. So the all three are correct. And there may be other correct answers. There may be other reasonable ways of constructing uniform chords, but all of them they may lead to different answers because the underlying mathematical questions are different.
Right. Okay. So it's not actually undefined. It's like the question is
undefined. They are all valid answers to three different mathematical questions. In one case, the omega is the angle swept. The other case, omega is the distance from whatever. No, where does the center land and all that. The random experiments are defined differently. The sample spaces are defined differently. All of them are valid and all of them are correct. You're getting different answers because the questions are different.
Yeah, apart from that, I do have some question regarding the assignments. For example, in assignment number 2, question number 2, the question says that script C be a collection of subset of E, let script D be an sigma algebra on E such that script C is a proper subset of script D. Then which of the following are true? One of the option given, like all of these options are given in like the proper subset. Like a script C is a proper subset of
no,
sigma
that
of D.
notation may not mean proper subset. It could mean just subset. Different authors use differently. So this just means that this does not mean that there are elements of B that this does not mean that A could be the same as B, right? So it could be that A contains a B and B contains an A, and therefore A equal to B. All that is possible. Okay, it doesn't mean that notation doesn't mean strict subset.
I was actually following the notation given in your notes, and that's why I guess.
Yeah, so I think we should write that if you want, but it's okay. We don't mean that strict subset. Okay.
Okay.
All right. Does anybody else have any other comment?
In assignment number 3, question number 3, let A be events such that probability of A given B is greater than probability of A, and for A probability of A and B greater than 0. like I have a question, like how is, like in what possible values can A and B take for which this equation would even be true? Because like A given B is strictly smaller set than probability of A, right?
No, no,
Like
that is not true. A given B is not, see, A given B is not an event. So you should look at, if you, you know, just to say conditional, okay, let me just write this down. See, conditional probability is a different beast. Okay. When you write probability of A given B as probability of A intersection B over probability of B. Okay. So in general, for this is defined for, so this is for some any event where probability of B is strictly positive. So you can define probability of dot given B, okay, as a probability measure from from F to 0, 1. Okay. So you have to put in various events here.
okay.
Just a different measure. Some people, you can write it as PB of dot if you want. It's a different measure. Okay. So this can be bigger or smaller. So this is a different probability measure. So it can be bigger or smaller. You cannot say anything.
Yeah, but like if you look at the formula itself, probability of A intersection B has to be strictly smaller than probability of A.
The numerator is strictly smaller, but when you divide probability of A intersection B by probability of B, you can get something bigger or smaller.
How is that possible given that probability of B is greater than 0? Like if you divide by some
No,
positive
that's not
number,
true at
your
all, right? So probability of B can be very small.
probability of B can be very small. In that case, it approaches an
Yeah, so you can have a situation where probability of A given B is greater than probability of A or less than probability of A, or everything is possible. Okay, you can construct very simple examples.
like what do you even mean by like a very small probability? Like
No, I mean, can you not make up an example where probability of A, just throw some dice and make up some events, right? Where probability of A given B is greater than probability of A. You can easily make up an example.
yeah, I can't think of anything on top of my head.
Just work it out. No, we just take the event that you're throwing two dice or something. Assume that B is the event that it's odd, and what is the probability that it's prime given odd, or you can make up stuff like that.
Yeah, but in that case, the probability of A given B will be smaller than probability of.
You make it up. You make up some examples. Okay. I think between even, odd, prime, you can make up some examples. Very simple examples can be made up where probability of A given B is greater than probability of A. Even in discrete spaces, you can make up such examples.
I still don't understand. Like probability of A intersection B upon probability of B is only like greater than probability of A if B probability of B approaches 0. And you can't have probability of B approaches 0
No, that's not
when
true. It's absolutely not true. You can have probability of A intersection B being greater than probability of A times probability of B.
like isn't that did it be proved in the theorem that it is not possible in the lectures?
It's very
Like
much
the
possible.
probability
Probability of A intersection B can be greater than probability of A times probability of B.
considering that probabilities are between 0 and 1 and the product of two numbers which are smaller than 1 will have to be smaller than either of them, right?
Yeah, but probability of A intersection B can be bigger.
Okay, so let me put it in a formal way. Probability of A intersection B, the greatest possible number for probability of A intersection B is probability of A times B, probability of B. We proved this in the class.
Absolutely not. Absolutely not. What you said is totally wrong. So you just take like, so I mean, I don't know if this will work out, right? You throw dice and you look at odd and p equals prime or something like that. Try calculating. Okay. 1 die, 2 die, you throw and calculate this. Okay. Don't remember, but I think something like this you can make up. Okay. So it's not at all the case. You can very well have probability of A intersection B greater than probability of A times probability of B is very much possible. Okay. Any other questions? I think Sujit Kumar had a question on, I think you had said something in the sheet saying it's a little too advanced.
Yes, sir.
Can you introduce yourself? Where are you from?
Yes, sir. I'm from NIT Calicut, PhD scholar.
PhD scholar. Okay. Who
Yes.
do you work with?
Sorry?
Who are you working with?
Sir, Dr. Vivek Mohan.
Okay. Yeah.
Sir.
If you're a PhD scholar, you should learn this stuff.
Yes, sir. Yes.
Yes.
Yes. So actually, I'm not having any base with this probability, so I feel it's really difficult for me to follow the lectures. Your classes are okay, but the content, I need to invest more time, I think. Because
yeah, you have to spend more time, rewind, watch again, right?
Yes, sir.
Yeah. Correct. But I think so. If you do the problems in the notes, I mean, there are notes online, right?
Yes, sir. Yes.
Yeah. And there are notes there. There are problems there. There are some exercises in the week 2 assignments were a little bit beyond what you should worry about. All this pi theory, lambda theory, those things are not needed for you. But otherwise, I think should be okay. If you're able to follow the lectures and do the assignments and do the back problems in the notes, I think you should be okay.
Sir, how can I expect the exam? Final exam will be?
Exam it'll have like some objective questions and some long problems, like 5-mark problems. Okay.
Okay.
There'll be a combination of objective questions and long problems.
So it will be MCQ, right?
No, it will be a pen and paper exam.
Okay.
In which there will be a few objective questions.
Okay, sir.
And then there's some problems you have to write the proof or whatever.
Okay.
You have to give a full exam. It's not on a computer. It'll be a traditional exam.
Okay, sir.
Okay. But
sir,
if you're a PhD scholar in NIT Calicut, you should learn probability at this level.
Yes. Sir, and I'm having a doubt in one of the lectures. Week 2, lecture 10. You mentioned the properties of probability measures. In that fourth point, you mentioned that inclusion-exclusion rule. Sir, that is P of A union B equal to P of A plus P of B minus P of A intersection B. And so can you please explain how we can extend that to n number of events? I did not actually get that point.
Yeah, there is an extension. What you're saying is inclusion, exclusion. So for 2 events, it is P of A union B is equal to P of A plus P of B minus P of A intersection B.
Yes.
Right? And for more events, you can write P of union AI is equal to sum over P of AI minus 2-way intersections. I think maybe you should write I less than 0. Plus you add 3-way intersections. and so on. Then -1 whole to the n minus 1, probability of I equals 1 to n. Right. So this you can prove. There's a simple proof coming later using indicator random variables. Okay. But for now, you can use induction on n. This is a statement. This is only a finite union. Remember, inclusion exclusion principle is applicable only for a finite value of n. Right. So this is a statement about natural numbers. So you can use induction. You can. So in the base case, this you know, right?
Yes, sir.
And you make the induction hypothesis for 1 through k and prove it for k plus 1.
Okay.
Okay, so it's a algebraic sort of an exercise. You can do it. Okay.
So, sir, my doubt is actually we are adding the third term. So individual probabilities are added and the intersections are subtracted. Then what is the significance of adding that third term? Which you wrote
so the high level idea is, see, just like here, if you add these two, you've counted the intersection twice. So you're taking out the intersection.
Yes.
So likewise, you're adding everything, then taking out all the two-way intersections.
Okay.
But if you take out all the two-way intersections, you've taken out little bit too much. You have to bring back the three-way intersections. Okay. If you want, if you want the picture, you can draw a Venn diagram for 3 or 4 and see. But beyond that, it becomes difficult.
Okay, sir.
Okay.
Yes, sir.
I will, if you want a model exam, I think you wanted a model exam, no?
Sir, if we can share a question pattern with solutions.
So maybe I will ask if NPTEL can share an exam which was, which was given in the past years.
Yes, sir. Yes. Sir, after week 12, covering all the portions, then it would be of great help for preparation and all.
Correct. So I'll ask NPTEL if they can pull out some previous exam.
Yes, sir.
Sir, regarding like the previous, it would be really also be helpful if we can get like previous years assignment questions and so on. Because till now, like I asked in the forum and I haven't gotten any valuable response.
So you want previous year's assignments?
Yeah.
That I don't know. Maybe we may have a significant overlap with what you're doing, I think. There may not be too many new ones. Okay. Yeah, and I don't know if NPTEL can share that.
Yeah, actually there are links for in the NPTEL website itself. And for some courses, those links are working. But for many other courses, those links are broken. And this particular course have broken links for previous year's assignment.
Oh, I see.
Yeah.
It may just be that it's probably just recycled bodily. That may also be, right? Maybe that's why it's broken.
Yeah, so I can get a full marks if I do this course again next semester.
In assignments, as regards assignments.
Yeah.
There's a bunch of offerings. You don't know which one will repeat again.
Yeah.
You see what I mean?
Yeah, I understand.
You may have to do it 4 times to get full marks. If you do it 4 times, you may get full marks anyway.
Yeah, like even the second or third time I might get a full marks, but yeah, I'm skipping that. So in the assignment number 1, like in the question number 5, this is like for function for mapping f e to f. Okay, there will be a function. Define a collection of script t as follows. Script t is equals to f inverse of a, where a is script f, and where script f is a sigma algebra on f. So like here for even f inverse to be a function to be defined, f needs to be actually bisection.
Yeah, so the TA told me about this question. F inverse is not like that. So if you have F inverse is not the inverse function, right? F inverse is the pre-image. Okay. So let's say this is omega, this is R. Okay. F maps omega to R. Okay. All right.
Right.
You take any set A. Okay. F inverse of A is the pre-image of A. Okay, is the set of all omega such that F of omega is equal to A. Okay, so it's like it's that those omegas that map into A.
Oh.
Okay, so this is not this object, this F inverse is not a function. It's an inverse image, a pre-image. Okay, so F inverse of A is a subset of omega. So you don't need to confuse yourself with saying that is F a bijective function, is the inverse defined and all that.
Okay, so like this might have already solved my problem, but I'm going to state it anyway. So for in the solution, we are actually freely able to take out the inverse actually. For example, here in the solution part, F inverse of union of Bn for all natural number n belonging to script T is equivalent to say like a union of all F inverse of Bn for n equals to n belonging to a natural number. Like I don't see why this statement is like true or even trivial.
This is not trivial. This requires a proof. I have it on your screen, right? You have to prove it. So you take some omega belonging here. You prove that that omega also belongs here, and vice versa. And likewise, you have to prove that F inverse of B complement equal to F inverse of B whole complement, right?
Yeah.
So these two things you have to prove you have to prove that these two sets are the same. So you have to take some omega here and prove that it belongs on the right side and vice versa. So the F is a function, okay? So that is a very important thing. It maps every element of omega to a unique element in R. Okay, so that's very important. Okay, so for example, if omega belongs to F inverse of B complement, okay, then F of omega belongs to B complement, right? That's the definition.
Yes, that is not it.
So F of omega belongs to A, I think. F of omega belongs to A, is what I mean. Okay, correct?
Right.
So this implies that F of omega does not belong to B.
Right.
Right? So implies that omega does not belong to F inverse of B.
Okay. Yeah, and then you can take
So that implies omega belongs to F inverse B whole complement. Correct?
Oh, yeah.
And so you have to this only proves what I just wrote proves this containment. You have to prove the converse also, right? So likewise, you can proceed. Okay.
Sir, can I ask one thing?
Yes.
Okay. Sir, at the beginning of the course, you mentioned that you will be offering a probability course in the next semester also, which is more problematic compared to this course, which is more theoretical. So, according to your opinion, which course will be more suitable for a PhD student?
I think so. If you are a PhD student in NIT, this is the correct course for you.
Okay.
See, that I mentioned, that was recorded 9 years ago.
Okay.
And we used to offer two different versions, one with some measure theory and one without measure theory, because the MTechs used to struggle.
Okay, sir.
And at some level, maybe if you're going to get an industry job or something, maybe all this is not needed.
Okay. Okay.
Right? But if you're a PhD student, you should learn all this.
Okay, sir.
Okay. Okay, Sishir, Pranav, Shyam, any other word where can you introduce yourself, Sishir? Hello?
Hello.
Hello? I cannot hear you.
Hello.
Hello?
Hello, sir. Good morning, sir.
Good morning. How are you? Where are you from?
Sir, I'm fine, sir. I'm from Nepal, sir.
You're from Nepal?
Yes, sir.
Are you able to follow?
Yes, sir. I'm following, sir.
What are you studying?
I am actually civil engineer, sir.
Civil engineer?
Sir.
Wow. It must be a little difficult for you, no? What are you studying, undergrad or?
Yes, I have just completed my master's, sir, and I was interested this in last semester, and I had gone through this your lecture series in 2 or 3 months ago, and when I saw it was offering in this semester the NPTEL course, and I joined, sir.
Okay, very good, very good. Do you have any questions for me?
No, sir.
Okay. Let me know if you don't follow something. Okay.
Sir, one not question. I was having just thought, sir. In other probability courses, there is no such major theoretic portion, sir. But here there is major theory.
Yeah.
Could you put light on what is its significance, sir? Significance.
Measure theory is a formalization of what we intuitively think of as probability theory, right? So at a high level, when you're dealing with discrete probability, like balls in urns or die or coin toss or those kind of things, where your sample space is discrete, then you don't need any measure theory actually. You can do fully without measure theory. Just like 12th standard, I think many students in India do probability. Maybe even you have studied probability in your 12th standard. Do you?
Yes, sir.
So 12th standard level probability you can do on discrete spaces. But the moment you have continuous like intervals and all that, right? Then you need measure theory. Okay, whenever the sample space becomes uncountable, then all this machinery becomes unavoidable. Okay.
Hello, good morning, sir.
Good morning, Pranav.
Sir, I've just completed my master's from IIT Hyderabad in mechanical engineering.
Okay.
Sir, I have doubt from one of the assignments.
Sir,
there was a question that there are n bags, and each bag has n-1 green balls, and remaining are the r-1 green balls, and remaining are blue balls. Sir, I was able to do that question, but later on, I was thinking about that. As you mentioned that choosing a probability space is crucial. So I was thinking that what was the probability space in this problem, and how I assign probabilities to that, because since the probability space is discrete, how I assign probability to those discrete points in the sample space.
Yeah, so it's easy, I mean, for a discrete space like this, there is no issue. You can just take all possible outcomes, and any subset of omega is an event, and you assign probabilities to singletons.
Yes, sir. So,
No,
sir,
that
I'm
means
asking.
whatever sequence you take the ball, right?
Yes, sir.
That will be a singleton event. For that, you have a probability. Either I think you're drawing uniformly with replacement or something, right? So that will have its probability. That's all.
So here we are assuming that we are using that traditional definition of probability that
Traditional definition means it's a uniform probability on a discrete space.
Okay, sir.
Meaning that if there are any elements, you assign 1 by n probability to each of them. That's all.
Yes, sir. So it is, sir, like that favorable outcomes upon total number of outcomes.
That is for the uniform. Yeah. So for the uniform case, that is correct.
Sir, for uniform discrete case.
Uniform discrete case.
Sir, I have a doubt can you please throw some light on independence of more than 2 sigma algebras?
Independence of more than 2 sigma algebras.
Yes,
so independence of 2 sigma algebras, you understand?
Yes, sir. So we pick elements from both and.
So you have omega. Okay, then there is, well, let's say there is omega fp. Okay, and f1 and f2 are 2 sigma algebras, which are sub-sigma algebras of f. Then f1 and f2 are independent if.
So if we take elements a1 from f1 and a2 from f2, yes, sir. Any
a belongs to f1, or a1 belongs to f1, and a2 belongs to f2 are independent events.
Yes, sir.
Okay, then you can have not just more than 2 sigma algebras, but an arbitrary collection of sigma algebras. All of them are sub-sigma algebras of F. This could be an arbitrary collection. This doesn't even have to be a finite collection. It can be an infinite collection or even an uncountable collection. Okay. So you would proceed likewise. So you, for any, so are independent. So these are independent sigma algebras. If for any choice of ai in fi, these ai are independent events. That's all. Now, what does that mean? It just means that, what does ai are independent event mean? This just means that for all I not finite subset of I, probability of intersection ai, I belongs to I naught is equal to product I belongs to I naught probability of ai. Okay.
Yes, sir. So, sir, here we can't count the number of conditions that are needed because
there are infinitely many conditions, right? But you are imposing only producting out over finite intersection. For every possible finite intersections, you should have product. And if you prove that, it's not like you can exhaust these things because they may be infinitely many. But if you can prove that for any subset, or I know a finite subset I naught of I, this is true, then you have AIs are independent. Once you understand what that means, you can understand what that means. Okay.
Yes, sir.
That's all.
Sir, I have a doubt, sir. Sir, as you mentioned, we should do the questions in the given and at the end of lecture notes.
Yeah.
So, sir, is there any solutions available to those questions?
Not sure. I don't think we can share that because they are. See, many are from Grimmett-Sturzaker and all. If you can look up Grimmett-Sturzaker solution somehow, you can find the solutions. All right. Yeah. So we are not releasing those. Those are solutions we are not releasing outside our IIT classes. type solutions.
Yes, sir.
But your assignment solutions, I hope you have access to, right?
Yes, sir. Sir, some of the questions, some of the solutions are, sir, not quite elaborate. So, sir, that's why I'm asking.
So you can ask which one is you don't know. You can ask. You can ask the TA. You can ask me.
Yes, sir.
Yes, sir. Like a more general question, like for example, those who are not from like studying from university, like IITs and like most other places don't have like very good availability for mathematical faculties. Like the NPTEL is certainly one of the way to study advanced mathematics for them. But like, are there any like, do you have any other areas where we can study?
I think it's better to do it under some structure like this, NPTEL, or there are many foreign universities, but they charge you a lot.
Right.
Right. I would say for people who want to get an economical education, and if you are motivated, I feel NPTEL is the best option. Right. I don't know if what else you can do. Yeah. So what did you do for your undergrad?
I'm actually computer science and BTech in computer science, which I'm in last year actually.
Maybe you can apply for you. Are you taking GATE?
Yes, I will be taking GATE most likely. Yes.
You do well and try to get to an IIT. It's as simple as that.
Easier said than done.
Yeah, you try your best.
And there are certain courses which are actually not available in NPTEL. Like for example, like I think the functional analysis course, which was not available till last year, like it is available from this year onwards. Like so, there are certain courses which are like simply not available on NPTEL.
I think there may be a few gaps, but there are many important ones. I think right now the portfolio is fairly good, and it's few gaps will get filled in the next few years, I think. Right? If not IIT Madras, there are many other IITs offering these things.
Yeah, for example,
ISC.
there is still not a course in advanced computational and theoretical science, advanced theoretical computation. So like what to do in those cases? Like they like IITs do offer these courses in their curriculum, but they are not available on NPTEL.
Yeah, it just means that faculty hasn't gotten down to doing it. Right? Yeah, there are some courses which are there, but sooner or later, I think this gap will be closed. It's already pretty wide, the portfolio of courses available. Chances are it will get recorded in the next few years. From 10 years ago to now, there are many courses. Okay, good. Anything else? We have another 5 minutes to go.
Sir, this is Shyam Zakaria. I'm a PhD student in NIT Calicut.
So you are Sujit Kumar's friend, or do you not?
We haven't met.
That's funny.
So I just joined this year. It's just started on July.
Which department?
So, computer science only.
Okay.
So for me, it's a bit difficult to follow. So we are week 5 only, reaching into week 5. So it is. Maybe each lecture for me it is taking almost 1.5 hours to grasp.
Right.
So, so I believe that I can cope up with when it is completing that course, right? I would be able to complete all the courses by the time. So I have the same question as Sujit, and how will be the exam? Whether it will be we have a written examination, or how
we'll have a written examination. Okay.
Yeah.
I think I answered that question. You will have a few it will be fully pen and paper. You will have a few objective questions and a bunch of problems to solve on a a real paper and with a real pen. Okay.
Yeah.
There'll be no computer related multiple choice. Okay.
Yeah, sure. And when I mean, all these lectures will be completed by maybe around 2 weeks before exams.
I think by
itself.
first week of October, no?
So when is the exam? Is the date should be fixed?
29th. 29th October.
29th October. I think, yeah, you will finish, I think, 2 weeks ahead of it or something, right?
Yeah, okay.
But I mean, you can take a little more time, but you can rewind it, replay it, and take a little more time. But I would say if you're a PhD student in computer science, you should learn this stuff. Even if it takes 2 attempts, learn it, right? You will be well off. You will not flounder on concepts.
Yeah, I totally agree on that side. It's, I mean, the concepts are very intuitive. So I mean, it's a great. I mean, it's good to learn this. But only thing is that it is taking time.
Yeah. Everything takes time. When I studied also, it took time.
Yeah.
Right? Everything is like that. Right? It's the issue is not that it's easy, right? The issue is that it's useful. Once you learn it, you will be on very firm foundation. Then it will become second nature. Everything is like that, no? In life.
Yeah.
Long division was such a difficult thing, if you remember.
Yeah.
Like finding new squares.
Total nightmare, no? Like that only. Everything is like that.
Yeah. This was actually a recommendation from Professor Pradosh P from IISc. So
yes, I
told
know
me to. Yeah. So told me to take this course actually. So yeah.
But how do you know Pradosh?
I was attending one of his key courses in IISc. So that's how I came to know that. So that is generative AI course. So certainly, I mean, he taught in the beginning of this sigma algebra and all, and initially on that course. So that's how he recommended to join this course.
Okay, very good, very happy. I think IISc, yeah, I think in IISc this course seems to be popular, even if they don't officially take it. They watch the YouTube videos.
Yeah.
So that's what when I go to IISc, that's what the students tell me.
Okay.
That they watch the videos is what they tell me.
Yeah.
Sir. Sir, I have a doubt, sir. After completion of the course, sir, will there be any project which I can do under your guidance?
See, normally there's a formal way of doing this where NPTEL offers internships for students who do well in the course.
Yes, sir.
For that, you have to get silver or something. There's some gold, silver, and all, no?
Yes, sir.
If you are, I think I don't remember the rules anymore, but I think if you're gold or silver, you can apply for these NPTEL internships, and you can, if you are selected, you can get to work with the professor.
Actually, yes. Sir, I've taken like multiple NPTEL courses, and in many courses, I was actually 0.1 topper of that course, and I still did not get any message regarding internship.
Oh, I don't know why that is. But yeah, you guys can apply, and if you, if you are in computer science, well, if you are in electrical engineering, you can definitely apply. But if you are in computer science, well, maybe you can apply. But some of you are in mechanical engineering, civil, and all. I don't know what I can offer for you, right?
Yes, I'm actually computer science.
If you're willing to, I mean, if you're looking at a master's option, you feel free to apply for MS or something. Okay.
Sir, I have just completed my master's in mechanical engineering.
So your master's in mechanical engineering. So I don't know if I will be able to offer an internship for mechanical engineering, right? That's the.
Sir, actually, I am interested. I was interested in maths-related course. So later I realized that electrical or electronics branch will be more suitable for me. So. So and I have a aptitude of doing things properly. So if you are able to offer some project, I can do some. Because sir, I'm also I am exposed to some communication courses like signals and systems,
Okay.
signal processing.
Yeah, so these kind of things you can write to me separately.
Yes, sir.
Pranav and Swarnam, whoever is interested. I have to think about whether I will be able to offer or not. But in the case of if you are looking for masters and all, I mean, if you are looking for actually officially applying to IIT Madras as MS or MTech or PhD, you go ahead. You are very welcome to apply. And I can tell you that if you have done well in this course, not just me, anybody else will also look at it favorably.
Yes, sir.
Okay. Okay. Any other comments?
Will you be taking more live courses, live sessions?
I can do one before your exam. What do you think?
Like
We are roughly halfway through the course, right? So I
Yes,
thought
sir.
I will have a live session since we are in week 6 or week 5 or week 6, whatever this is.
Yes, sir.
And I thought that then maybe we can do one just before your exam. Is that okay?
Sir, I think probably after 1 week after the contents are over. So, so by
that
that
will be
time
good.
we'll be able to make some preparations so that
Okay.
we'll be able to ask more questions.
Sounds good. So that will be what, early October or mid-October? When is that?
That
I
will
think
be mid-October.
By
Mid-October.
mid-October. Yes, sir. Yes.
Yeah, you guys can send me an email around September 30th. One of you just remember to send me an email. Okay, and then I can have one more live session. Okay.
Yes, sir. Yes, sir.
Sounds good. Thank you, guys.
Yes, sir. Thank you.
Sir.
Thank you.
Thank you,
Bye-bye.
sir.
Very fortunate to have an interaction with you, sir. Thank you.
We're very happy to have. Thank you. Bye.
And Shyam, are you there?
Yeah, yes, Sujit. I'll call you in your number.
Okay. You are from Kerala only?
Yeah, yes.
എവിടെയാണ് സ്ഥലം എവിടെ?
ഞാൻ കോട്ടയം.
കോട്ടയാണ്. ഇപ്പൊ